this is Phil Thomas, New Era Systems. I'm looking at a very nice little buck. It's an NJT 8318. It's an 8-watt buck, KU-Band, full frequency range of 13.75 to 14.5 gigahertz. As it's set up, you can see it is connected to a crossguide coupler and dummy load. In the background, that silver unit is an optional 48 volt DC power supply. This buck will work either with 48 volts coming over the IFL cable, or if your modem does not support 48 volts, external power supply will provide the same voltage through the MS connector. In this case, I've got a Comtech 570L modem that does provide 48 volt DC. We had one of our standard 24 volts converted, and we can use it for this test. And finally, we're going to monitor the output on this spectrum analyzer and make sure everything works as planned. So, I'm going to go to the Comtech EF data 48 volt, and I'm going to turn the transmit on. And we see an immediate signal. The Comtech EF data frequency is set to 950 megahertz, it's L-band of course. It's also got the 10 meg reference turned on. If I turn off the 10 meg reference, I wouldn't get any output from the buck. So we can see under these circumstances that everything works perfectly with the 48 volt input from the modem. Now I'm going to go back to the modem and I'm going to disconnect the 48 volt input. Okay, now we have no input shown on the spectrum analyzer. My next step is going to be to connect the exterior power supply through the MX cable. Now with the modem buck power supply off, I'm connected directly to this external power supply. This is waterproof. It doesn't come with the buck. We ordered it separately from someone or other, less than $100. It can sit outside, and that's the best thing about it. At the moment it's connected to that power strip, which in turn is connected to a 220 volt supply. But it could easily be connected to 110 volt. This power supply is agnostic, it doesn't care. So as you can see on the spectrum analyzer, we've got a good signal. .75 gigahertz, that's the low end of the buck range. Well, I proved that it works both with the modem power supply or with the external power supply. So let's connect up the power meter so we can have a look at the power output. This is an 8-watt buck, so let me get that going. Okay, we're set up. We're looking at the modem, of course, on top, and the power meter. Power meter is connected to the crossguide coupler and dummy load. On the modem, let's look at the power. It's neg 30. So what we'll do, we'll increase this a little bit, and on the power meter you can see it's 33.7 dBm. It's about 2.1, 2.2. You can see on the lower section it registers watts. Okay, so we're going to up it from neg 30 to neg 28. And we're up now to 3 watts. We'll continue to do this until we get to about 8. Currently at 5.3 watts. On the dBm we should be seeing about 40 dBm before we're finished. Okay, where are we now? We're at 7.4. So I'm not going to take it up in such big increments. I'm going to move it over and we're going to go up to 23.5. See what that gives us. That gives us, again, we're at 7.8, 7.9. So let's do just a little bit more. All of these bucks, by the way, if they're called 8 watts, they'll normally go higher. Okay, 23 even. We're at 8.52, so just about 9 watts. And that's as far as I'm going to take it. It won't do any harm to move it a little higher, but why take the risk? Okay, so we've seen with this buck two different things. It will work with the 48 volt buck power supply. If you have a modem that doesn't have a 48 volt buck power supply, you can get one of these external AC power supplies and connect it directly to the buck. And so finally, just to make sure that we could get 8 watts or 9 watts out of this, we did a quick test using the power meter to register the output. Okay, that's it. That's all we're going to do for today. Thanks for watching. See you next time.